Okay. The next type of reaction I'm going to discuss is elimination. But before I start with the example of elimination, let us first discuss about what type of elimination do we have. Okay. So first is we have even elimination and we have E2 elimination. जैसे SN1 and SN2 था वैसे ही E1 and E2. So what is the elimination? Elimination is nothing but, for example, if I have this two carbon, let's say it is having X here and this is having H here. Okay. Now X can be anything, not only the halogen. So what generally we are expecting here, there will be loss of HX, there will be loss of HX, and I'm going to end up with formation of alkene. This is my elimination reaction. So now here there are two different ways of giving the product. सबसे पहले let us talk about even elimination. Now when I'm talking about even elimination, यहाँ पे हम क्या बोलेंगे, the CX bond जो है ना, the CX bond, this will be broken first. Okay, so this is dissociated first. CX bond पहले ब्रेक होगा. ओके. CX bond X अगर चला गया तो क्या फॉर्म होगा यहाँ पे, carbocation, right? So in short I'm going to get the formation of carbocation, and then the proton will be lost. Then proton will be lost. So first sequence is what? The CX bond will break, right? Then there will be dissociation, sorry, to give the carbocation, and then there will be loss of proton to give the elimination reaction. Okay. Now in the first step there is only dissociation of X. It is unimolecular reaction. This is unimolecular reaction. Now if you talk about the second one is E2. Now E2 में भी अलग अलग type है, E2 elimination में भी. Okay. Now E2 elimination if I say एक होता है, I'll say इसको E1 ही बोलेंगे. ठीक है, E1, but I'm going to call it as E1 CB. Let us talk about this first. This is E1 CB, that is elimination, unimolecular है, but this is carried out in presence of what? Conjugate base. अगर मैंने इसमें इस रिएक्टेंट में बेस डाला तो बेस क्या करता है, क्या एब्स्ट्रैक्ट करेगा? एक्स एब्स्ट्रैक्ट करेगा या प्रोटॉन एब्स्ट्रैक्ट करेगा?
प्रोटॉन.
प्रोटॉन. तो यहाँ पे क्या होगा, पहले दिस इज लॉस्ट फर्स्ट, प्रोटॉन इज लॉस्ट. अगर प्रोटॉन लॉस हुआ तो क्या फॉर्म होगा?
कार्बन है.
anion फॉर्म होगा, anion formation, right? And then CX bond will be broken. ठीक है. तो इवन में कितने टाइप है? इवन में दो टाइप है. If you carry out this reaction without a base, the X will be broken because it's a polar bond. And if you are using base, then the CH bond will be broken easily. Okay, so there are two type of even mechanism. And then E2. E2 में क्या होगा? CH and CX both are broken simultaneously. जैसे तुम्हारा SN2 है. Okay, both are broken simultaneously. But since I'm saying both are broken simultaneously, both are leaving group, दोनों लीविंग ग्रुप एक ही साइड से निकलेंगे या एंटी निकलेंगे एक दूसरे से? देयर विल बी एंटी एलिमिनेशन, दैट वी हैव टू रिमेंबर. देयर विल बी एंटी periplanar. This is also important. Periplanar means what? Plane. So anti, but they are going to get removed from the same plane. That we have to remember. Most of the cases anti elimination ही होता है. It is preferred. Okay, but sometimes there are cases where the sin elimination is competitive. I'm saying competitive, that means it is to equal tendency, it is possible. So what kind of elimination will happen, whether it is anti elimination or whether it is sin elimination? It completely depends on the nature of substrate, the nature of electrophile you are using, the type of leaving group you have, then what are the solvents you are using. Sin elimination कब कब होता है? जब sin elimination is possible when this anti elimination is difficult. तो ऐसे केस है जहाँ पे anti elimination नहीं हो सकता, possible ही नहीं है, वहां पे जिन एलिमिनेशन हो सकता है. Okay, so now we are going to take the example for this elimination reaction and then we are going to find the product formations. ठीक है. सबसे पहले यहाँ पे मैंने लिया है मेंथिल क्लोराइड. मेंथिल इज लाइक मेंथॉल, अगर तुम्हें पता है. इट्स अ साइक्लोहेक्सेन डेरिवेटिव. ओके, ये तुम्हारा मेंथॉल है. तो इसमें ना ये 3 chiral centers है. There are 3 chiral centers which are present in this. Okay, now depending on that, just remember 3 chiral centers मतलब 2 raised to 3 कितने हो गए stereoisomers?
8.
8 stereoisomers. Okay, so these are different stereoisomers. उसमें से हमने ये अभी जो लिया है वो मेंथिल क्लोराइड है. Chloride means what? Instead of this OH I have a Cl here, so I have taken here the methyl isomer. मेंथिल आइसोमर. व्हाट इज दिस मेंथिल स्ट्रक्चर? मेंथिल स्ट्रक्चर मतलब अब ये जो 3 कंपाउंड है ना, इनके अलग अलग कॉम्बिनेशंस पॉसिबल है. ये 8 आइसोमर्स मतलब क्या है? कभी ये एक्शियल होगा और ये इक्वेटोरियल होगा, तो अलग अलग कॉम्बिनेशन. देयर आर 8 डिफरेंट टाइप. सो राइट नाउ वी हैव टेकन अ मेंथिल आइसोमर वेयर यू कैन सी हियर this methyl group and this isopropyl group, they are equatorial, as well as this chlorine is at equatorial location. Okay, I'm arranging this to the another isomer, or I'm going to flip the ring where I can see now this methyl group is at axial position, this isopropyl group at axial position, and this chlorine is at axial location. Okay, if you see, this is the most stable isomer. Why? Because all the groups are at equatorial location, so it is most stable one. बट वेन एवर इट इज गोइंग टू गिव यू रिएक्शन, इट विल टर्न टू द एक्शियल. जब तक वो एक्शियल नहीं बनेगा वो रिएक्शन नहीं देगा. इक्वेटोरियल आइसोमर्स जो है ना तुम्हारे, वो तुम्हें रिएक्शन नहीं देंगे. सो एक्शियल आइसोमर्स आर गोइंग टू गिव यू द रिएक्शन. नाउ रिमेंबर, एज आई सेड, द टू ग्रुप्स which are going to we are going to remove them, they have to be anti periplanar to each other. तो अब यहां से हम क्या निकालने वाले हैं? क्लोरीन. ओके, अब लेट्स कॉल दिस एज अल्फा. This is my alpha carbon, which is going to lose the chlorine. How many beta carbon I have? 2 hai. Okay, let us call this as beta and I'm calling this as beta dash. Beta के पास कितने प्रोटॉन है? बीटा के पास कितने प्रोटॉन है? ये बीटा है और ये बीटा डैश है. ठीक है, तो
1.
बीटा के पास 1 प्रोटॉन. क्या लोकेशन है बीटा का? प्रोटॉन का लोकेशन क्या है? एक्सियल पे या इक्वेटोरियल पे? कैन इट बी लॉस्ट with this chlorine? Are they anti-periplanar to each other? No. So
No.
is it possible to lose the electron from the beta, sorry, is it possible to lose the proton from beta carbon atom? No. Now look at the beta dash. Is it having proton?
Yes.
How many proton?
2.
2. Axial पे भी है और इक्वेटोरियल पे भी है. बट इसमें से लॉस कौन सा होगा? Only axial will be lost, right? Equatorial is cis to chlorine, axial is anti to chlorine. Okay, so if I number this is 1, 2, 3, 4, 5 and 6. So now between this 2 and 3 carbon atom, what is going to happen? The second carbon will lose the proton and third carbon will lose the chlorine, so that between second and third carbon there will be formation of double bond. Okay, and if the double bond is formed, I'm going to end up with this product. This is called as 2-menthene because there is a double bond between second and third carbon. Okay, now we are taking the another isomer. We have changed now conformation. Instead of methyl, I'm taking neomethyl. So what is the difference between methyl and neomethyl? Understand. Look at this. Methyl and isopropyl. They are at axial equatorial location, and look at the chlorine. It is at axial. पहले कैसे था वो? इक्वेटोरियल ही था. अब वो कैसा है? एक्शियल. तो ये हो गया मेंथिल और ये हो गया नियोमेंथिल आइसोमर. ओके, अब देखो, दिस इज माय अल्फा कार्बन. Again, how many beta I have? Carbons. Okay, let us assume this as beta and this is as beta dash. Okay, beta, look at the beta carbon. Can it lose proton with that chlorine? Yes, because the proton is what? Axial.
Axial.
And this is also axial. Chlorine is also axial. So if I number this 1, 2, 3, 4, 5, and 6, can the double bond be formed between 3 and 4? Can the
Yes.
double bond be formed between 3 and 4? And if it is formed, I'm going to end up with this product. This is called as menth 3-menthene. Okay. And if, look at the beta dash, is it having the proton which is anti to chlorine? Yes, this is also having. So यहाँ पे भी proton loss possible है. Therefore, I'm ending it with the how many products? I'm ending it with the two different products. But इसका अगर second और third के बीच में bond form हुआ, double bond, so I'm going to get the same product which I'm getting from the methyl chloride, right? So I'm getting here two product. One is 2-menthene and one is 3-menthene. So I'm getting formation of two different product. So whenever I'm getting formation of two different product, the two alkenes, the major and minor product can be decided according to which rule? Sedgwick rule. So what Sedgwick rule says? More substituted alkene is formed as a product. तो अगर दोनों में से कंपेयर करोगे तो तुम्हारा 3-menthene है, it is more substituted, right? Because it is having attachment with this isopropyl group, right? So it is having more substitution. Therefore, this is formed in 75% amount and this is formed in 25% amount. ध्यान क्या रखना है? When I start with methyl chloride, I'm getting how many product? Only one product, and that is 2-menthene. But in how much amount? 100% amount. But when I start with neomethyl chloride, I'm getting how many products? I'm getting two products. Out of that, 3-menthene is the major product. ओके, तो देखो कॉन्फर्मेशन चेंज कर दिया, ये कॉन्फर्मेशन और ये कॉन्फर्मेशन, कॉन्फर्मेशन चेंज किया, मुझे प्रोडक्ट जो मिल रहा है वो भी अलग मिल रहा है. एक मुझे 100% एक ही प्रोडक्ट दे रहा है, दूसरा कंपाउंड मुझे 75-25% प्रोडक्ट दे रहा है. Okay, and even this kind of the stereochemistry or the stability wise it is also different. Menthol is giving me 2-menthene as a major product, neomenthol is giving me 3-menthene as a major product. Okay, so as I'm changing the conformation, I'm getting different products. That is the cyclohexane derivative, the conformations is affecting the product formation.